Hi, my name's Christina. Today I will be talking about the Beckmann and Schmidt rearrangements, and these are nitrogen rearrangements, and both mechanisms are very similar. The starting material, a ketone, and the product, an amide, are also very similar, but the source of nitrogen differs depending on the Beckmann or Schmidt reaction. And these reactions are run under acidic conditions, and they both contain a 1,2 migration of an R group to the nitrogen to form this amide, and the R group could be an alkyl or an aryl. The Beckmann reaction uses hydroxylamine, so this NH2OH, and then the Schmidt reaction is using the hydrozoic acid. And when both these reactions, a ketone is rearranged into an amide under the Beckmann and Schmidt rearrangement conditions, which I'll talk about next in this mechanism. It's easy to end up with some mixtures based on just the selectivity and depending on which R group migrates. So now let's get into the mechanisms.
Okay, so here we have a Beckmann rearrangement, and we're just going to activate the ketone, and what's going to happen is that the nitrogen is going to act as the nucleophile, which is going to create an alcohol, which we will form into a good leaving group so that eventually the nitrogen lone pairs can kick off this leaving group, because we want to get to a ketoxene, which will eventually help us get to our final amide product. So here the nitrogen lone pairs are going to kick off the water, and we're just gonna have another proton transfer to get to this ketoxene, which is a crucial step in the mechanism. And then once again, we're gonna have another proton transfer. And here, what's gonna happen is that there is going to be a 1,2 shift of the methyl group to the nitrogen, and this will end up being in the anti position to this leaving group here, which I'll explain.
So usually with these reactions, what's going to happen is that the R group, that is anti to the leaving group on the nitrogen at one point in the mechanism, this R group is going to be the one that migrates. As you can see here, it is now bonded to the nitrogen.
But anyways, we have these two intermediates here. We'll decide just to attack the most stable carbocation intermediate with the water that we just took off. And what's going to happen is that here we're just going to have another proton transfer. As I was just talking about before, this nitrogen is in the anti position because this methyl was anti to the leaving group on the nitrogen, and then this intermediate here is just going to tautomerize to a more stable amide product. So here is the Schmidt mechanism, which is almost analogous to the Beckmann rearrangement. However, some of the intermediates will differ due to the different reagents from the hydrozoic acid. So again, we're in the presence of a Lewis acid, and we're just going to activate our ketone. And then here, our hydrozoic acid is going to act as a nitrogen nucleophile, which is going to attack our carbonyl. And once again, we're just going to make a good leaving group with a proton transfer. And here we're again just going to deprotonate because N2 is a good leaving group, and we can have the nitrogen form a double bond, which is going to kick off this leaving group. And then here N2 is a good leaving group, and all at the same time, just like the Beckmann rearrangement, we're going to have the methyl migrate to the nitrogen. So now the methyl group is going to be bonded to the nitrogen, and the N2 group is going to kick off. And then once again, we have these two cation intermediates. For this sake, we'll choose to attack this intermediate just to show you how the end product will still be the same. So the oxygen is going to attack this carbon, and then we're going to see another proton transfer just to stabilize the nitrogen. And once again, we want our product to be tautomerized, so we're going to have another proton transfer, which is going to form an alcohol, and then once again tautomerize to our more stable amide product, all through the Schmidt mechanism.
So here's a reaction. I want you to pause the video and decide which reaction you believe it is, whether it's the Beckmann or the Schmidt rearrangement. And just remember, one of the biggest differences between these two reactions is the source of nitrogen used in the reagents of the reaction. And here, because the source of nitrogen is coming from the hydrozoic acid, we are going to have a Schmidt rearrangement.